Hello everyone, and in my previous video I have told you how to derive the wave equation, and in this video I am going to tell you how to solve the problem of wave equation. And the fastest method is D'Alembert's solution. D'Alembert has given the formula for wave equation. See here, D'Alembert's solution for one-dimensional wave equation, and in my previous video, I have already derived the one-dimensional wave equation. UTT is equal to c square into uxx. That means del square u by del t square is equal to c square into del square u by del x square. And x is a real number and t is greater than 0. Okay. And the given conditions are u of x0, u of x0. 0 means u of xt because u is a function of x and t, and x is the point and t is the time, and u is the displacement. I have already told you. Use the displacement at the point x at time t. Okay. So u of x0 when time is equal to 0, that means it is the initial condition. And at the point x, that means it is the initial displacement. It is the initial displacement. And I have taken the initial displacement as f of x. And the initial velocity ut, that means del u by del t. Derivative of displacement, u is the displacement. So the derivative of displacement with respect to time is called the velocity, and time is equal to 0. That means initial velocity, and I have taken g of x. And both the ends, I have already told you, both the ends of the string should be fixed. That means u of 0t when x is equal to 0, starting point. At time t, it is fixed. That means there is no displacement. U is equal to 0 means there is no displacement. And final end, this is the initial end fixed, and the final end fixed means when the length is L, that means at the end position there is no displacement at time t. Okay, so we have taken the time t, so the displacement at the end point is also 0. That means the final end is also fixed. And the D'Alembert solution of the above Cauchy problem for one-dimensional wave equation is u of xt equal to half of x plus f of x plus ct plus f of x minus ct plus 1 by 2c integration of g of y with respect to y from x minus ct to x plus ct. Here, in place of y, you can take capital D or tau or x, anything, because this is a definite integral. So the variable is dummy variable, so you can take anything. Okay, it does not matter what is the variable there. Here, f is the initial displacement, as I have told you, and g is the initial velocity. Okay, so let us see how to solve the problem. Here, the question is that utt is equal to c square into uxx. And u of x0, that means this is the initial displacement which is given as 0, and ut means del u by del t, initial velocity is given 1. Here initial displacement is equal to 0, f of x, and initial velocity g of x is equal to 1. And the D'Alembert solution is, see here, initial displacement is 0 and the initial velocity is 1. So the formula for wave equation given by D'Alembert is half of f of x plus ct plus f of x minus ct plus 1 by 2c integration from x minus ct to x plus ct g of y dy. Here f is given as 0, so this quantity becomes 0, this one becomes 0, that means this total quantity becomes 0. Clear? So I have not written 0. So 1 by 2c integration x minus ct to x plus ct, in place of g I can write 1 because it is given 1. So 1 into dy, integration of y dy is y. Here, so I can write here, see here, it is equal to 1 by 2c integration of y from x minus ct to x plus ct. Here, then upper limit minus lower limit. In place of y, I have to write x plus ct minus in place of y, x minus ct. So after opening the bracket, x minus x cancel out, ct plus ct twice of ct, so it becomes 1 by 2c into twice ct. 2 cancel out, cc cancel out, remain t. So this is the answer. Clear? See another example. Utt is equal to c square into uxx u of x0, that means initial displacement is sin x, and the initial velocity is x square. That means this is f of x, this is g of x. See here. Here f of x is equal to sin x, and g of x is equal to x square. Clear? So the D'Alembert solution is u of x is equal to half of f of x plus ct, f of x minus ct, plus 1 by 2 c integration x minus ct to x plus ct, g of y dy. How? F of x is sin x, then f of x plus ct will be equal to f of x is equal to sin x, then f of x plus ct, that means sin of x plus ct, sin of x plus ct, and this one is sin of x minus ct. Bracket close. You should put the bracket in the proper way. Plus 1 by 2 c integration x minus ct to x plus ct. In place of g of y, I can write x square. That means it is y square. G of y it is given, so y square into dy. And this is the formula: sin a plus b plus sin a minus b. Sin a plus b plus sin a minus b. The formula is sin a plus b plus sin a minus b. You want to remember the trigonometry formula: sin a plus b plus sin a minus b, 2 sin a into cos b. 2 sin a into cos b. So 2 sin a, here a is x, into cos b, here b is ct. So 2 sin x into cos ct. Okay. So let us see here. 1 by 2 c integration of y square is y cube by 3, and 3 I have taken outside, from x minus ct to x plus ct. So this becomes 3 2 is 6, 1 by 2 c, and in place of y write upper limit, that means x plus ct whole cube, minus in place of y write lower limit x minus ct whole cube. And here 2 to cancel out, sin x into cos ct, and you can open the whole cube formula, a plus b whole cube, this is a minus b whole cube. After opening the whole cube, you will get these two quantities. Okay, so this is sin x into cos ct, and if you open the whole cube, expand this one, so you get this one. Okay, so now let us see another question. utt is equal to c square into uxx. Here u of x0 is equal to log of 1 plus x square, that means f of x, which is the initial velocity, and ut of x0, that means initial velocity is 2. This is g of x. Here f of x is log of 1 plus x square, and g of x is equal to 2. And the D'Alembert solution is half of f of x plus ct plus f of x minus ct plus 1 by 2 c integration g of y dy from x minus ct to x plus ct. Here f of x is log of 1 plus x square. See, mindfully you should see here. See here. Log of 1 plus x square, that means f of x plus ct, f of x, log of 1 plus x square, f of x plus ct, in place of x, write x plus ct, in place of x, you should write x plus ct. So log of 1 plus x plus ct whole square, plus log of 1 plus, in place of x, write x minus ct. Here, 1 by 2, see, in place of g of y, you can write 2 into dy. Okay, so see here, expand this one, a plus b whole square. 1 is there, plus x square plus c square t square plus twice of ab, that means 2x ct. Here also log of 1 plus a minus b whole square, x square plus c square t square minus twice of ab, 2x ct. Okay, so the same part I have written here, and here in this part take 2 outside, and integration of dy is y. So from x minus ct to x plus ct. This is x plus ct minus x minus ct. You will expand the bracket, open the bracket, it will become x minus x plus ct. So minus x plus x cancel out here. So ct plus ct twice of ct. So 2 to cancel out, remain 2 to the 4 ct. If you will cancel out 2c, it will become 2t. Okay. So this is all about the D'Alembert solution, and I have given some homework. If you will do these questions, it will be better. See here, I have given 7 questions, and here see here, utt is equal to c square into uxx. In place of c square, I have written 9. That means the value of c is 3. Okay, and f of x, g of x. Okay, and here c square into uxx. In place of c square, I have written 49. That means c is 7. Here in case of C square I have written 16. That means here the value of C is 4. And in this case the C is C. Okay. So in our problem it will be given the value of C and the initial displacement f of x and the initial velocity g of x. Okay. After that you have to solve the questions. In my next video I will tell you the question will be in the form of paragraph. That means the word problem, and how to solve those questions I will tell you. Okay. And those questions are very much important in for B.Tech students and physics honors students basically. And from their book I will give you I will solve the questions and then I will give you some questions for homework. Okay. So try to solve these questions, and if there will be any doubt, then you can ask me. Okay. So you can now ask me in my WhatsApp number also. I have given here. This one is my number, and you can message me if there will be any doubt. And after that, I'll tell you if there will be any problem. Okay. In my next video, I'll tell you some more questions, some critical problems based on wave equation, and after that, I will tell you how to solve the heat equation and Laplace equation problems. Okay. So till then, bye bye.